Right. Before we kick off and have our first speaker, I thought I would do like the briefest little brain tease, just to like warm us all up, get us all in the mood, so that we can deep dive. Right, I'm going to ask you guys to think of a number between 2 and 10. That's quite easy. Start off easy. Now, have you got your number in your brain? Yeah? Now, multiply that number by 9. Now, you're wishing you picked a smaller number. Okay, you got your multiplication of 9. You've done that. Now, you're going to add the 2 numbers together. Have you done the math? Is that, yeah, great. Okay, now, last bit of maths, you're going to take 5 away from that number. You got your number in your brain? Yes? Have I lost you all? No. Okay, now, if your answer equals 1, you're in group A. Okay, you're in group A. If your answer equals 2, you're in group B. If your answer equals 3, you're in group C. And if you got the number 4, you're in group D. So everyone's got their groups. Okay, now I want you to think of a country in Europe beginning with your letter. I'm testing maths, geography, all of your school stuff. Have you got your European country in your brain? Yeah, and at home, do this as well. Now, I need you to think of an animal, not a bird or a fish, but an animal beginning with the second letter of your country. Have you found that animal in your brain? And now I want you to think of the color of the animal from the second letter of the country of Europe. Yeah, you got it. Okay. So, are you thinking of a gray elephant from Denmark? Yeah?
I had an emu from Denmark.
An emu from Denmark, very close. Well, that's because I'm a wizard, and I can read your brains, but no. I got this little math trick, so I was like, that's really cool. I want to do that. Okay, now I'm going to pass you on to someone who's going to give you way more entertainment than that. Let me get my notes. Here we go. Right. First up today, well, second up today, technically, we have got Dr. Ken Tankersley. He's an associate professor of geology and anthropology at the University of Cincinnati and a member of the Pika tribe. He's the primary investigator of several significant events, including the Hopewell Airburst event, the Brenham impact event, the Eagle Creek impact event, and the Younger Dryas Airburst event at Sheridan Cave. We focus a lot on the Younger Dryas, of course. She's taken all the spotlight, as she does, Queen. But there are other airbursts that help paint the picture that we're trying to see. And with Dr. Tankersley's most recent contributions, he's fast-forwarding impact science 12,000 years and bringing it into the American heartland. So a huge round of applause for Dr. Kenneth Tankersley.
Oesta. Sanalei Oginali. Good morning, my friends. So this morning we're going to cover a bit of territory. And I do want you, George pointed out that I should really point out that I started out as a skeptic. So in fact, when Firestone first contacted me, he said, we're going to publish an article in Science about the occurrence of nanodiamonds or impact diamonds. And I know you've spent several decades working at Sheridan Cave in northern Ohio, and you have evidence of the Younger Dryas. Well, indeed, Sheridan Cave is one of those few places on the planet where you can put your finger on the end of the last ice age. And more importantly, we have a nice black mat. And I respectfully declined. And the reason I declined is I knew that the glacial deposits was full of diamonds. A lot of people don't realize if you don't want to buy a conflict diamond, you can buy diamonds from the Canadian Shield area. And the glacial tills and the glacial outwash are absolutely full of diamonds. I was so naive. That was not the kind of diamonds that Firestone was talking about. So just as a entry into what we're talking about. I don't know how much you know about Sheridan Cave, but basically it was a serendipitous discovery. If you recall the summer of 1988, the landscape dried up. We were in a time period of extreme drought. And in northern Ohio, it's pretty much a flat, featureless landscape. I've worked in caves around the world, and Sheridan Cave was nothing like I had ever seen. So the idea of having a cave in a glaciated landscape just didn't make sense to me. There wasn't enough surface for dissolution of cavities to occur. But I wasn't thinking of ancient caves. And the entire landscape turned brown except this green round area. And a guy by the name of Dick Hendricks, who ran a commercial cave called Indian Trails Cavern, thought, well, perhaps this green area, what's going on, it's like a wick in a kerosene lamp. And what we're looking at is a very large sinkhole that will lead into a very large cave system. And the water is being drawn up to keep the grass green in this circular area. So he got a clam bucket, which you can see in the slide. That clam bucket's big enough to pick up my truck and several others. And he started digging, and sure enough, he was correct. There was a large sinkhole. And then we came in. The sinkhole was full of extinct fossils. Animals such as Arctodus simus, the short-faced bear, one of the most lethal predators in North America. And it had never been discovered before. For that matter, a Pleistocene deposit of this antiquity had not been seen before. The barren ground caribou, Rangifer tarandus, its bones were exposed there. Servalsi scotti, the stag moose, its bones were there. Both peccaries, Platygonus compressus and Mylohylus nasutus, the long-nosed peccary, were both there. In fact, there was a large suite of over 65 different animal species found in Sheridan Cave, and as many botanical remains as well. But what was interesting, that in addition to having a deeply buried cave, we also had extinct fauna, but up came a flagstone artifact. An artifact distinctive of early Paleo-Indian, what we call the Clovis cultural complex. And they were all coming out of the same stratum. Well, that had never been seen before in the Midwestern United States. At that time, there were only 11 deeply stratified, well-dated Clovis sites with extinct faunal remains. And here we have one in Ohio. So we started excavating with funding from the National Science Foundation and later help from National Geographic, the History Channel, the Animal Planet, the BBC, Nature, and the list goes on. We excavated down 100 feet. No one had ever excavated in Ohio 100 feet below the surface before. It wasn't easy, but here you can get some idea. We had a climbing rope rigged to haul our buckets to the surface where we did all of our screening. We water screened all of the sediments. I went to Switzerland one summer to talk about Sheridan Cave, and I wanted to see how they excavate Pleistocene layers in caves. And one of the things I noted is they built a platform that they could lay on above the sediments and excavate, and that's what you see here. And we uncovered a black mat, a massive burned layer. And I thought, I wonder if this occurs on the surface. So we excavated on the surface next to the cave as well. And you can see the stratum here very well pronounced as well. we ended up finding a plethora of extinct faunal remains, including Platygonus compressus, the flat-headed peccary. In fact, the most recent dated, you're looking at the most recent dated, in other words, the last known example of Platygonus compressus. In the same stratum, we have Castoroides ohioensis, the giant beaver, which was actually more like a giant muskrat. It didn't have the flat tail of a beaver, but nevertheless, it was in the same layer, and it radiocarbon dated to the same time period. It was the last known example, the most recent specimen that's ever been dated on the planet to this date. And we found more Clovis artifacts. We started uncovering what you're looking at is a triple exposure of a Clovis bone point. You can see the bevel and the cross-hatching, and you can see on the left the specimen as it was coming out of the ground, and a scanning electron micrograph showing impact damage. It had been used. It's most likely manufactured from mastodon. These artifacts are extremely rare, but because of the constant temperature and humidity in the cave, the bone artifact was well preserved. More excavating, a very distinctive Clovis spear point, a Clovis projectile point, as we say in archaeology, and looking at various views. Again, from the same layer that produced the extinct megamammals, it has the burn layer, and again, we're talking 50 feet below ground. And perhaps one of our best smoking guns was another Clovis bone point, and that's a perforated innominate. An innominate, if you put your hand on your hip, that's part of your pelvic girdle. That's your innominate. And here you can see one perforated and a Clovis bone point. So to get some idea, say, well, is this really Clovis age? And we looked at the suite of artifacts. All of them are distinctive, both the flake stone Clovis artifacts and the two bone spear points, all consistent with the Clovis cultural complex in a layer that dates to the end of the Pleistocene, that dates precisely to the Younger Dryas, and in a layer with over 65 species, and including extinct megamammals. I hated to do it, but as you know, there's always doubting Thomases out there. People will say, oh, that's not true. They said, if it's really that old, why don't you cut up one of your bone points and date it? In other words, have a direct date. We had people saying, oh, those artifacts occur in archaic time periods in New England. I've never seen one, but I thought, all right. We cut a centimeter out of the bone, and what we extracted very carefully, what you're looking at, are collagen fibers. We removed all the inorganic fraction of the bone, which, as you know, is calcium carbonate and calcium phosphate. And that left us with the organic collagen fraction, which allowed us to directly date the bone. And as you can see, it dates to the Younger Dryas. It dates to the Clovis cultural complex. So after years of excavation, of course, we did find one of the butchered animals that we found was a very large snapping turtle, which was likely serendipitously found in the cave. So for me, how did Clovis, how were they involved in the cave? Well, basically, it was a locality where there were food resources. If any of you have been in cave regions, especially in the Tag area, the Tennessee, Georgia, and Alabama region, if you throw in Kentucky, which has the largest cave system in the world, here in the southeast, we have more caves, longer caves than anywhere else on the planet. And if you've been in them, you know they're warm in the wintertime, and they're nice and cool in the summertime. But the other thing, in karst areas where caves occur, there are sinkholes, and animals fall into the sinkholes, and many times they survive. So animals are being like people. Other animals are, I mean, we're basically animals too. We want to be warm when it gets cold. And if you get too close to the edge, what happens? In you go. So imagine Clovis people coming by and seeing a sinkhole with a cave coming off the sinkhole. And there's animals down there. They climb down and dispatch them. So it was also a nice natural shelter. There's a sinkhole entrance, but at the bottom of the sinkhole, there's a huge cave. So again, cool in the summer, warm in the winter. Even though we're talking about the Younger Dryas, it still provides that. Usually caves, the mean annual temperature of a cave is the average temperature in the locality of the karst region. And then in terms of what was actually going on, the idea of a cache. Does everyone understand what a cache is? Back in the 60s, we called it a stash. But anyway, that's another story. But nonetheless, to give you some idea about caches, I worked on many documentary films for Nat Geo, History Channel that involved the Arctic. And we always had a consultant. And one of our filming in a place called Point Barrow, Alaska. I don't know how many of you have been to Point Barrow, Alaska. It's the northernmost portion of the United States. And at Point Barrow, Alaska, there's a place called Igloovigac Pass. And the Inupiat are the indigenous people who live there. You know them as an Inuit. Some people still use the old term, which is a derogatory term called Eskimo. But so Inupiat, I asked him, I said, do you ever cache things? And he said, what's that? Do you ever bury things or hide things for future hunting and survival? And he said, yes. He says, you see a Igloovigac Pass out there? And I said, yes. He says, see where that ridge spur comes down right to the ground? And then about 10 feet in front of it, there's a large boulder. He said, walk 25 paces from that boulder in a straight line with that ridge and you'll find a caribou rib. He said, go ahead and dig up where the caribou rib is and you'll find everything you need to survive. And I said, you mind if I look at it? He says, if you take something from it, put something of equal value and cover it back up. And I said, I was fascinated. And I said, when's the last time you've been there? He said, I've never been there. I said, how do you know it's there? He said, everyone in the village knows it's there. There are many others, and we all know. In other words, caching behavior is a means of survival. It's what we find among hunter and gatherers around the world and documented ethnographically until band level peoples were put on reservations. But that made sense to me. What I didn't understand was consider all the past ice ages. We've had many ice ages. We just had an outstanding discussion about Earth's history and the beginnings of life. I mean, we just heard a discussion about what we in geology call deep time. Deep time. And in deep time, there was a time our planet, you might call it a snowball planet. We've had many, many glaciations, but we've never had an extinction event. What happened? We've had the planet cool. Now, a lot of people don't realize that during an ice age, what happens is it's not the winters are extreme. Believe it or not, in an ice age, the winters are warmer than they are now. It's the summers that are cold. You don't get much of a summer, and ice starts to accumulate. So much so it starts to move. Well, that's happened many, many times throughout Earth's history. When I was an undergraduate working on my baccalaureate, I learned there were 4 glaciations named after states: Wisconsin, Illinois, Kansas, and Nebraska, going back in time. By the time I was working on my master's degree, we were up to 8 glaciations. By the time I was working on my doctorate, it was 16 glaciations. By the time I was doing my postdoctorate, we don't know how many glaciations, because each glaciation covered up the one before. But in every time, there was no extinction event. All of the ice ages came to a very slow and gradual end. Not the last one. All of a sudden, we were going into a nice, slow, gradual warming period, and then all of a sudden, it got cold again. That's the Younger Dryas. And it lasted about the time, it was a profound global climatic change. And during that period, imagine if you're a Clovis person and you're born at the beginning of the Younger Dryas. There were mammoths, mastodons, short-faced bears walking the landscape. By the time you're elderly, they're gone. In a human lifetime, we saw the extinction of species. And I knew at Sheridan Cave, with over 65 species, what I could see by directly dating the species, a pattern emerged. Of the over 65 species, there were 5 species of what I call microteens, mice, shrews, that they could no longer survive in the Sheridan Cave area, and they moved to geographic areas where they could still survive. And then there were species that essentially downsized, became smaller. We used to think, for example, bison lantifrons, we called it a genus and a species. The one with the horn cores out over a yard each side of the cranium, straight out. And then we had bison antiquus, which had horns like this. And of course, you know the modern bison, which the Lakota call tatanka, about this big. Well, thanks to DNA being able to extract clone, albeit degraded, DNA from bone collagen, we now know that they're all the exact same species. It's bison lantifrons, it's bison antiquus, and bison. They're different at the subspecies level. In other words, these massive mega mammals got smaller through time. Genetically, they're the same. To give you some idea of genetic similarity, you all realize, I hope, that you can get a blood transfusion from a bonobo. Think about that. Pygmy chimpanzee. Me too, all of us, we're genetically so close to a chimpanzee, we can receive a blood transfusion from them. We don't they're endangered species. But nonetheless, so think about the bison downsizing in response to climate change. So you could move away, you could downsize. Well, we found some carnivores that also moved, what we call things like pine martens, weasel-like animals. They moved away. But most of the species stayed the same. They were right where they are because they could still make a living. And only 2 species went extinct. Other species like the short-faced bear or Cervalci scotti, they had already gone extinct. Only 2 ended at the Younger Dryas. Why? Because they could not downsize, they could not move, and they could not survive at the end of the Younger Dryas in the environment that was left behind from the climate change. So Sheridan Cave seemed to have all the answers, except what in the world happened? Of all the ice ages, going back deep into geological time, something happened. Well, what happened to me was this guy, Dr. Alan West. He's what happened to me. So we invited him when he's out here somewhere. But anyway, we invited him, the Department of Geology invited him to the University of Cincinnati to give a talk. And one of the things that impressed me, you've all seen the moon projected in the back, I assume. And think about the Earth. We've been impacted every bit as much as the moon's surface is. And I thought, well, here's Alan. He's the world expert on nanodiamonds. And here's an opportunity for me to throw out my idea about glacial nanodiamonds. I just go destroy the cosmic impact hypothesis. So he says, you've been excavating Sheridan Cave. Can we go there? I said, sure. And we go up, and I had our black mat exposed in multiple parts of the cave. One part a quarter mile away from the other part, one different ends of the cave. You can see one on the left, a highly oxidized area, and a gray area, one that's in a reducing environment, oxidized versus reducing. The carbon's still carbon, it's still because carbon is an inert element, so it still survives. So I thought, all right, first of all, Alan explained to me, no, these are impact diamonds. These aren't the terrestrial diamonds that you see. These are generated from impact. And so, all right, let's do a blind test. I have all this stratigraphy. We dug 100 feet down. We'll take random samples from areas. I'll know what the layers are. Alan won't. And we'll see what he can find. Up came nanodiamonds, just like he had published with Firestone in the journal Science. I said, where'd you find that? Guess where he found it? In the black mat. That's science. People don't realize in science, as scientists, although many of us who are academicians, people say we live in ivory towers, and in many cases we do. But our purpose in science is to do everything we humanly can to reject our hypotheses. No one proves a hypothesis. I've been a federal witness in a court of law. And Dr. Tankersley, can you prove? Well, of course not. No scientist can prove anything. If you want proof, go see a mathematician. Mathematicians, they can prove. They have proofs. We don't as scientists. But what we do is we do everything we can to reject our hypotheses. And if we've done that, we feel that we've gotten as close to the truth as humanly possible. I'm not immortal. No scientist is immortal. So at that point, we had evidence beyond reasonable doubt, and all of a sudden, it was right in front of me. But what was really the Younger Dryas impact event smoking gun to me was this: Lonsdaleite. Lonsdaleite and multiple samples. And again, Alan, where did these come from? And he gave me the number and the letter. I looked at my sheet. It's the black mat. He worked blind. I always work in the laboratory. I too do all my work blind. I don't want to know where things come from when I'm doing any type of geochemistry. That way I don't form any kind of bias. And that's what Alan did. He's a true scientist, truly remarkable. Lonsdaleite. Whether or not you know it, terrestrial diamonds are cubic in their crystal structure. Crystals are amazing things. They reflect the geometric arrangement of the atoms. If you have a quartz crystal, it doesn't matter if it's 6 foot tall or 6 microns. It's still a hexagonal crystal. It's hexagonal because it's reflecting the geometric arrangement of the atoms. Here you can see in the X-ray diffractogram, you can actually see the hexagonal. See the stop sign in the dots? That's the crystal pattern of Lonsdaleite. That cannot form on this planet. And there it is in Sheridan Cave, in the burn layer. If that wasn't enough, and again, keep in mind, when we're evaluating cosmic impacts, we use what we call proxies. A proxy is a way to measure things. A lot of people don't realize when Einstein was talking about relativity, everything we do is relative. I mean, keep in mind, I know everyone stood on a scale today and weighed themselves to compare to yesterday, right? Now, how does your scale at home compare to the scale in your doctor's office? Are they the same? I got news for you. Even the clock that's counting down my time is not the same on my watch. In other words, we have a standard measurement. Whether or not you know it, there's a gold bar for a foot, a gold bar for an inch, there's a gold bar for a meter, there's a gold bar for a centimeter, and all rulers, metric and English, are relative to those. They're just proxies relative to those measurements. So we want to have as many different ways of measuring an event as we possibly can. And here's a close-up of scanning electron micrograph. And again, that's 50 nanometers. These are tiny. But it's still a beautiful crystal of Lonsdaleite in the X-ray diffractogram. Another proxy is carbon spherules, having a high iridium content. And when you look at, this is the concentration at Sheridan Cave of impact diamonds, carbon microspherules, magnetic microspherules, and magnetic grains in the layer, but not above or below any of the other layers throughout the cave. For me, in a court of law, that's beyond reasonable doubt. As scientists, we have to hold ourselves to the same level as a court of law, beyond a reasonable doubt. So if you look at the black mat and our suite of radiocarbon dates, again, you can put your finger on the end of the last ice age. You can put your finger on the Younger Dryas. Sheridan Cave became the 12th well-stratified, deeply buried Clovis site with extinct fauna and evidence of the Younger Dryas cosmic impact beyond a reasonable doubt. I became a believer. Can't believe I use that word. But, and of course, there's the date and the evidence. So, the idea of a slice of a comet hitting the thermosphere and catastrophically exploding. Sheridan Cave was close. There were even burned megamammal bones. So I thought, wow, I have to admit, this was a lot of fun. Now what? I want to still have fun. And Alan suggested to me, he said, well, you know, you need to read a book called The Cosmic Serpent. Has anyone read The Cosmic Serpent? So it's a wonderful book that talks about comets coming through and coming close to Earth. And he talks about how indigenous peoples around the world describe these cosmic events as serpents. Some people call them dragons. You ever wonder why so many people have dragons? The Maya, the Aztec, in China, all around the world. And I thought, all right. So here I am in the United States, and if I look at the entire archaeological record as we know it, where do we find cosmic material? One time period, one geographic area. It's called the Hopewell Cultural Complex. They lived about 2,000 years ago. And they left a remarkable record. You can go around the world and you'll see Hopewell archaeological sites. The largest geometric earthen earthworks in the world are here in the United States. They're remarkable artifacts at any natural history museum, anywhere. When I went to Siberia, when I was working in Siberia, there was Hopewell artifacts. The greatest collection's actually in the British Museum. We know what they looked like, but they made artifacts out of meteorites. Not just any meteorites. What you're looking at is the rarest of all meteorites. It's called a palisite. It's a nickel-iron meteorite, but you're also seeing crystals of olivine. On the left, you're looking at a bead made of meteoric palisite, and on the right, you're seeing the raw palisite, both which came from Hopewell archaeological sites. And there's a lot of them. I thought, all right, now that Dr. Alan West has taught me the kinds of proxies that we need to evaluate a cosmic event, I'm going to use those methodological tools kit, if you will, and search the Hopewell to see what's going on. Well, being an enrolled tribal member of the Pequot tribe of Alabama, I wanted to see also people forget, indigenous peoples around the world are incredible astronomers. It's just not the English-speaking world. Indigenous peoples have been recording. Vine Deloria Jr. wrote about this in a book called Red Earth, White Lies. And he argued that our oral histories record actual events. So I went to the first site that meteorites were found on a Hopewell site, and that's the Turner site. And I found these artifacts. The snake, the serpent, is made of chlorite from here in North Carolina, just an hour's drive away but it ended up in Hamilton County, Ohio. That's a freshwater pearl for an eye, and although this is black and white, it's a beautiful green mica, and it's covered with red ochre. And on the right is another drawing of an artifact that was fragmented, put back together. In Cherokee, it's called Uktena, the great horned serpent. The Haudenosaunee, the Lenape, all have the same word for it, as do the Shawnee, Tecumseh. It means sky panther. But the sky panther is actually a very complex being. It's a dragon-like creature. And all these tribes living in this area have an oral history that an event occurred. I said, all right, I'm off and running. So I selected a suite of sites spread across the Hopewell, Ohio Valley area, and I started looking. First place I went was the Turner Earthworks. And there is a carbon layer. Well, as archaeologists, we know that carbon layers are common. Buildings burn down. We have HARs. There are many reasons to explain a carbon layer. But one of the things I started thinking about, the Turner site was excavated in the 1800s. They didn't use screens. They didn't use 1/4 inch. They didn't use 1/8 inch. They didn't water screen. They didn't use flotation devices. I said, we're going to do that when we excavate. And what you're looking at, are the meteorites found in the 1800s. The first meteoric material found on a Hopewell archaeological site, A and B, found by the excavators Frederick Ward Putnam and Charles Metz, working for the Harvard Peabody Museum. And down below are ones we found. These are only a millimeter across. Basically pea gravel. We call it pea gravel because it's the size of a pea. And these are pallasites. Those little bumps on D, those are olivine crystals. In other words, how did these get here? The fact that we had microscopic or even handheld size specimens suggested something occurred there. And using the same techniques of the Younger Dryas, we had micrometeorites. When you look at C, those are platinum crystals. A lot of micrometeorites, people who study micrometeorites call those Christmas tree patterns. And that one fused in the atmosphere. You can see it's fused to another. But what really got me was across the river is an earthwork called the Milford Earthworks. And for me, I'm sorry, I admit I was biased. I saw a comet. And what's interesting to me, when you're there, that comet earthwork is built on top of a hill above the village. Native American symbol systems are created so anyone who's part of that culture can understand that. Those of you who speak Cherokee know that when I said, Oesta Sanalei, I said good morning, if you're part of that culture. If you're not part of that culture, it sounds like just words or gibberish. But there's a symbol. But more importantly, if we look at that symbol compared to a place called Tunguska, has anyone heard of Tunguska in Siberia? In 1908, most people don't realize it's not only famous for the impact. Here we see a historic picture along with what it looks like today. It also produced the first recognized sedimentary meteorite. Sedimentary meteorite. monstrous, as big as these monitors in front of the stage. But when you look at B are drawings by the people of near Tunguska who witnessed the event. Compare that with the earthwork of the Hopewell people. For me, the association was unquestionable. So when you look at that, I decide, okay, let's excavate underneath the earthwork. Well, on the left, you can see that bright colored, that's recent, and you can see how disturbed it is. That's the earthwork. And right beneath it is a burn layer. In other words, the symbol of the comet occurred after the construction of the earthwork. And of course, beautiful examples of micrometeorites occurring in the layer. I thought, all right, I'm off and running. So now I started looking at other Hopewell sites. So I thought, all right, this is the Little Miami River Valley. I'll go over the Great Miami River Valley. And Hopewell focused, like people around the world, major archaeological sites are at river confluence areas. And here you can see a nice burned layer, very much like the burned layer we found for the Younger Dryas. Not only did we find micrometeorites, we found microtektites. Does everyone understand what a tektite is? It's actually terrestrial material, but it's from heating from a cosmic event that literally melts the sand or silt or clay particles, whatever they are, in the area. Extreme heat. And here we had them at what we call the Jenison Guard site. So I thought, oh well, on top of the hill, on the other side of the river, there's a hilltop, what archaeologists back in the 1800s called a fortifications. We now know they're just water management features. We decided to excavate a village and see if there were, how the village was impacted. Well, much to our surprise, the village was burnt to a crisp. Burned timbers. And here, take a look at the cross-section of earth. It wasn't just the buildings that were burnt, but there was intensive burning beneath the buildings as well. And here in this trench, you can see a cross-section of the burned layer, how it burned the clay subsurface beneath it. And again, in the burned layer, micrometeorites, very classic. And because there were water management systems, I wanted to think, okay, did the village burn down? Was it torched by an enemy? Was there a disease and they torched the village? What happened? Well, thanks to water management system, we had a thick layer of ponded sediment, what we call lacustrine sediments. So I could look at stable carbon isotopes going back through radiocarbon dated time and see if there's any change in the vegetation. Well, without engaging in a discussion of stable carbon isotopes, you can see in the bar graph where the Airburst event occurred. It's different, which suggests that plants with different photosynthetic pathways responded differently. There was a change, a profound change in the vegetation at the same time the village burned. So I started going to another well-known. Well, let's go up near Pennsylvania, the Marietta site, which is strewn throughout the town of Marietta. There's the burned carbon layer. And we looked at various places, a ditch that was collecting water between a berm and Conus Mound, and Quad Mound as we call it. What you're seeing where my colleague Steve, the late Steve Myers is pointing to, that's the plow zone, and down below it is a burned layer. Every classic, and again, micrometeorites. Every classic Hopewell site we went to, I thought, well, I'm going to head south. I live in Kentucky. let's go down by Berea, at a place called Indian Fort Mountain, beautiful knobs region. Up on top, pronounced charcoal layer, micrometeorites. Foster's earthwork, this is a LiDAR image. And you can see the burned charcoal layer. You can see within the earthwork where it was excavated. Classic micrometeorites. Note the one in B, you can actually see olivine. And again, these are microns in size. The Kronosky, one earthwork right after another, the same story over and over again. I thought, okay, burned layer, radiocarbon dated, all to the same time period, and micrometeorites, those are just proxies. There are other proxies we can use as well, as we've used with the Younger Dryas. I thought, well, platinum. Now, there's 3 ways you get platinum, platinum spike. Right now, you're getting it from your catalytic converters. So in our modern stratum, there's a positive platinum anomaly. In other words, there's a spike of platinum from air pollution. But as we go back in time, there's only 2 ways you get a platinum spike. One is a catastrophic volcanic event. And I found that working at Tikal in Guatemala. But the other is in a cosmic impact event. And look what we found. The Turner site. This is the concentration as you move away of the sites we examined, and our prevailing south winds are from the west. So I thought, okay, I need another proxy. I'll use iridium. Iridium is a non-terrestrial element. The same thing. What if we compare that to the maximum size of micrometeorites? The same pattern. What I all pointed to is a cosmic impact at the end of Hopewell. Hopewell people didn't disappear, but this complex society that was spread over a large geographic area, all of a sudden we're seeing I dare use the word, cultural devolution. So we have evidence, oral histories, and we have symbols which show that the Hopewell peoples did in fact witness the Hopewell event. Now, I love what George said. Great quote. Heresy is a cradle, and orthodoxy is a coffin. I was a salmon swimming upstream. You know how many Hopewell specialists like the idea of a cosmic impact at the end of Hopewell? They say, oh, you cosmic people, or you're using cosmic impacts to explain everything. And now we have Tankersley explaining the end of Hopewell to a cosmic impact, where in fact we can explain it from trade. For Pete's sake, obsidian from Wyoming, silicified lignite from North Dakota, galena from Illinois, conch shells from Florida, mica from here in North Carolina, shark teeth from the Atlantic coast. You don't have to explain it with a cosmic event. People were trading these things. And I said, okay, where are you trading it? They said, well, the best match for this very rare meteorite is the Brenham event. So this time last year, I was in Kansas excavating. No Ohio archaeologist bothered to go to Brenham, Kansas, and excavate. The strewn field of that impact is over 800 hectares. A hectare in acreage is 1 hectare is 2.5 acres approximately. And there are 80 hectares of impacts, craters, what we call penetration funnels. Maybe this is why Ohio Valley archaeologists didn't go there. It was 112 degrees when we were excavating. It looks like, I know, rock hard. It's prairie soils, rattlesnakes, although it does look like dances with wolves. But so I went to the only one of these 80 hectares of impact sites had been excavated. So we excavated there. We found the layer and we dated it. What's interesting, beneath where the meteorites occur is a rust layer. Well, the date we got was 1,000 years after Hopewell. Hopewell couldn't have got meteorites from there because the event hadn't occurred yet. So I thought, let's excavate another crater. And we did. Here you can see a palisite from that, again, about the size of a football. These aren't microscopic. Some of these are so big, I can't lift them. And again, over 1,000 years after Hopewell, ants are bringing up palisites. Again, that tractor's pulling a magnetometer. That's how you find out on the field. And as fast as that tractor can go, that's how we find penetration fields. And here you can see on the LiDAR image below. This palisite, we actually got the sediment. I have it upside down, but it was rested on the oxidized layer. And something else, no one thoroughly described the meteoric material. Here you can see what it looks like. The olivine and the nickel iron. That's what olivine looks like from this event. It's not what it looks like in the Ohio Valley. What's interesting, the olivine crystals are cracked. Here you can see a scanning electron micrograph of the crack. So we don't know whether or not that's from the meteors hitting one another in space and causing the crack, or thermal change as it passes through the thermosphere, or are they cracked from the impact with the Earth? I can't give you that, but those are three possibilities. And the other thing we found was there's a great degree of heterogeneity. They are not homogeneous. Everyone wants a sample that looks like sample C. People who collect meteorites. But in fact, there's a wide range of both in terms of the mineralogy and chemistry from this one impact event. Very few people recognize that. And we also identified minerals not associated in any way with the Ohio Valley. Here we're looking at a nickel magnesium oxide. You can see the green mineral. By the way, that's big enough I can sit on that. That's a boulder-sized palisite. Do we get micrometeorites? Yeah, but they're 2 millimeters across. They are the size of peas. And you can see the olivine. When we look at the age, 1,000 years after Hopewell. Hopewell people could not possibly have collected in Kansas because the event hadn't occurred. And again, when we think about indigenous people, the Pawnee who lived there, they saw the event and they recorded it. On the left is their star charts. The Pawnee are incredible astronomers. And on the right is a petroglyph near the impact site. And you can see the human figure standing up, and you can see the stars represented as crosses. That's the way the Pawnee do it. You can see they've come down to the ground. They're falling from the sky. Well, it's not the only. Just like the glaciations, we've had cosmic impacts through time. And it's not, will we have another cosmic impact? The question is when. So closer to home, I thought, well, I'll look in Kentucky. Note the color of the soil, just like that in Kansas. And there we have, again, palisites. And this impact event, think about that. That's almost 4,000 years old. There are many other impacts that we don't know about. There are so few. I am encouraged by people like Mark Young, who's making this the focus of his life's work. Young people who are now recognizing these impacts. Looking at the geochemistry, these are significant events. But I would argue, I'd leave today reminding a good place to understand the past is with Indigenous oral histories. They didn't write them down. It's passed down generation after generation since time immemorial. Indigenous peoples around the world have recorded cosmic events. And as scientists who investigate cosmic impact events, we need to listen to Indigenous people. Thank you.